I welcome you back to my channel. So today we are going to discuss about information theory. This information theory comes under the subject Digital Communication EC 8501 for third year students. So what is information? What is the need for information? How are we going to measure information? And is information and probability related? So this is the subject of discussion for today's class. First, we'll start with information theory, but before that, we need to understand what is a communication system. So as we already know, a communication system is nothing but transfer of signals from the transmitter to the receiver via a communication channel. So basically, any communication system involves a transmitter, a receiver, and a channel via which the information or the message signal is being transferred. So why is information theory required? This particular message signal which is being transferred from the transmitter to the receiver needs to be accessed. So which means that I need to find out how much of information is there in that particular message signal. So how to calculate information? So this information theory helps us in determining the information content present in that particular message signal, leading to different source coding techniques for efficient transmission of message. So information theory becomes really important as it measures the information, which helps in implementing different coding techniques to that information and transmit the data. So how do we measure this information? First of all, we need to understand how is this information related to probability. Let us take an example. Let us consider an event, that is sun rising in the east. Sun rising in the east is a very probable event. That is, everybody knows that sun is definitely going to rise in the east. So which means that what is the probability that sun rises in the east? Definitely the probability value is going to be 1, right? So but does this event carry any information at all? This particular event does not carry information. Why? Because everyone in the world knows that sun rises in the east, and there is no surprise or there is no uncertainty, there is no information in this particular event. Let us consider another example where sun rises in the west. So what is the probability that an event like this happens? If an event like this happens, it's going to be a very big surprise. So which means that it's going to be a very big information. So information content of this particular event is going to be really high. But what do you think is the probability? If anybody is asked what is the probability that a sun rises in the west, what would be the answer? The answer is 0, because probability that sun rises in the west is going to be definitely 0. But what about the information in this particular event? What if this event happens? But this particular event happens, the information content is going to be very high. So what is the relationship between information and probability? So the information and probability are inversely related. In the first case, where sun rises in the east, the probability is 1, but the information was 0. In the second case, where sun rises in the west, the probability is 0, whereas the information is very high. So which means that information and probability are inversely proportional. So using this particular relationship, we can get, or we can arrive at an equation for information. So removing the proportionality constant, we get information is equal to logarithm of 1 by p. So information is inversely proportional to probability. So there is a inverse proportionality. So that inverse proportionality can be removed with the help of a proportionality constant log 1 by p. Thus we get an equation for information, and this particular information has the units bits. Bits stands for binary digits. Thank you.